welcome to the channel. This video is going to be about again another video on credit risk, where we are going to build a model which will predict the possibility or probability of default, probability of someone being defaulter. Okay, so by now I hope you understand what default means, etc. If you don't know, I'm leaving a link into the description section. You can just give it a watch and you will understand what probability of default is. Now the point which you should notice is here I'm going to download the data from Kaggle, and this recording is, I would say it's a reality recording rather, I would say. Okay, what does that mean is I'm not first practicing the thing and then doing the recording. I'm going to do it on real time, or in real time rather, I can say. So and I'm going to keep the level of this video is absolutely manual, so that's something you would find me using very less of the automated things. Okay, I'll be exploring the things manually. So that's where I recommend, if you are the beginner, then this is going to be best for you. You will be understanding the things in detail over here. Okay, so let's just jump start with the video. Okay, so here this is the button. I'm going to leave this link into the description section. Just click that, this page will be opened, and click on this data will be downloaded. When you download this, it is going to be in compressed zip format, and you can open this. What I did is I opened it and I placed it in a separate folder here in tables, and here I have that data available. Now as soon as I had the data available, what I did is I jumped directly to the Jupyter notebook, and over here I have just imported basic libraries, right? Basic libraries which you might be very much familiar with: pandas, numpy, seaborn, and matplotlib. Okay, and after that here I'm just reading the data. This is the thing which I have already done, and I think it is pretty much a basic thing which you can do very well. Okay, now the next thing I'm going to start with is exploring this data first of all, right? So for to explore that, what I'll do is let's just see what is the shape of this data. So it says these many records and 12 columns. What we see over here is all the columns which this data has. Now let's just see the statistical description of this data. Describe. Okay, over here you see 1 2 3 4 5 6 7 8. Only 8 columns are reflecting. However, if you remember, we just checked that it had 12 columns. Why it is showing only 8? Because out of 12 only 8 are numeric columns, and describe gives you the statistics of the numeric columns, not for the categorical columns or alphabetic columns. Okay, character columns rather, I should say. All right, lot of talks. Now let's just dive into the numbers, or I can say the statistics. Let's have a look at the person's age. What it says is over here the minimum age is 20 years, which is very much practical. If somebody is applying for a loan, he or she is expected to be greater than 18 years old. But you see this 144 years old. Who on this planet at this point of time is 144 years old and applying for a loan? What exactly that he or she is going to do with the loan? So certainly this is the data error which I would be deleting from my data. Now you let me know into the comment section what exactly that you feel you should be doing and what you are trying. All right, now the next one which I am going to look at is person income. So this is something which we will see further. We will try to plot it and then we will see its distribution. I'm not going to make any decision on this column at this point of time. Next, if I see person employment length, see who is the person who is employed for 123 years. I mean, it in present time, the retirement is 65 somewhere. At least in India, it is 60 to 65. Okay, so who on this planet is working for 123 years? I don't think so, right? So again, this one is something which looks unpractical to me, which I would be deleting. Again, you let me know what exactly that you are going to do while you are building the model and how it performs. Now in the loan amount, that looks that's something, again we will see the distribution later on. Interest rate is also something we will see later on. Status is nothing but it is simply telling you whether it's a defaulter or non-defaulter. Loan percent income, this is nothing but debt to income ratio, right? And a CB, person credit history length, how long the credit history has been for this person. That's what it is saying over here. So the maximum is 30 years, so this person is having 30 years long credit history. All right, so what we found on I mean not relevant is this and this. So I'm just going to go ahead and delete these two things. Okay, so before I do any further modifications, what I would do is I would just make a copy of this data so that originality of the data is remains, right? So let's just say credit risk copy equals to credit risk dot copy. I don't want to spoil the originality of the data, so that's where I'm just keeping it. Now the next thing which we are going to do is we are going to delete this part. Okay, so I'm going to say copy risk credit risk, or let me just make it smaller. Credit risk CR risk, I'm going to say as credit risk, and age removed equals to credit risk where person age. So what I will do is, in my thought, what I'm going to do is anyone who is greater than 90 years old, I'm going to delete that. So let's analyze that first. So credit risk dot pivot table, I'll do a quick analysis. Pivot table index, and over here I'm going to use person age. Values we can put anything. Person income, let's say you can put any column. Okay, is count. Let's just see what is it that you are getting. All right, so this is what you are getting over here. Or here I'm going to say not person income, but I'll put another column. Let's just say columns I'm going to put over here, and into this I will put this one, loan percent income dot reset index and dot sort values by person age, ascending equals to false. Ascending equals to false. All right, now I'm confused whether it should be single equals to or double equals to. It should be single equals to. All right. I just get confused sometime. Okay, all right, so why it is what it is. Okay, loan percent income, I should not use loan percent income, rather I should use loan status, whether it's a defaulter or non-defaulter. That was an incorrect thing which I did. Now let's just see on this part. So the person who is greater than 70 years old, let's see, the person who is greater than 70 years old, the chances of them are being the number of those type of customers are very less, and the probability of default, number of default is almost null. Okay, so what I'm going to do is, in my data I'm going to take a call while building this model, that whoever is greater than 70 years old, I'm going to delete that data. What do you think? Is that a good idea? I think that's a call which I would require to take. In my model, I'm not going to consider any data point where the age is greater than 70 years. I would not like to provide any loan on that. Okay, that's simple, right? Whenever I'm making any decision, I would not like to provide any loan. I'm trying to reduce the possibility of risk. So simply I'll delete all those persons, all those records where the age is greater than 70. Okay, so that's it. I'm just going to do this. Okay, now you let me know what exactly that you did with your data, and then we will see. Okay, here I'm going to say less than 70 years. All right, and then let's just see, this is removed. Now let's just check the shape of this. Now we have 13,000, 32,561. Initially, how many we had? If I check out the shape of credit risk dot shape, I had 81, 32,581. Now I'm left with 61, means 20 records are deleted. Okay, now this is done. Next thing which I'm going to do is I'm going to focus on length of employment, right? Let's just have a look on this length of employment. So let's just click this again. I'm going to create another pivot on that pivot table, and inside that I'm going to say index equals to, you might find this video a little lengthy. If you're seeing that it is too slow, you can feel free to watch this at 1.5 x speed, or maybe on 2x speed. That's going to be absolutely fine. Okay, over here, next thing which I am going to do is person employment length. Let's just see what is the thing that we have, and in columns again I'm going to consider the status, loan status, whether it was default or not non-default. Values, let's just consider person income again, person income over here, and then aggregated function I would use count, and then reset index, and then sort values by employment length, and that is descending, sorry, ascending equals to false. That's what I need to say. All right, let's just hit run and let's just see what's gonna happen. All right, so 123 is unpractical. We need to remove that. That's for sure. There are two records for that. What is the minimum is that minimum length of employment that we have, that is 0 years, and with that we have this many records. The number of records are quite significant. It says 0 years they have been employed. All right, I'll keep this for now. I'll not delete this. I will keep that for bivariate analysis. Okay, I'm just all right, I had paused the video because I didn't want to entertain you with the dog's noise. That's why I just paused the video. Now coming back to the point over here, what we see is 123. There are two records with this. So what is the practical length of employment? So let's consider at 18 years, anyone is allowed to start their career at 18 years, right? And by 65 they generally get the retirement. So difference between 18 years and 65 year is approximately 47, isn't it? 18 or to 20 and 40 60 and then again 5, so 47 years. So anything where the employment length is greater than 47 years, I will delete that. Okay, I will be deleting that record. So let me just take that call and let me proceed with that. So for that, what I'm going to do is, here I'm going to say person emp removed equals to this, no, this data actually, and then over here again this one, then comes this employment length. If that is greater than 47 years, then I'm going to delete that record. Okay, you with me? Dot shape, let's just see. Oops, why is it saying just two records? No, sorry, here I need to keep those records. I'm not deleting it. Actually, I'm saying ki wherever the age is less than 47 years, just keep them only. All right, now here we got, here is what we got. Okay, so here it says 31,665. So quite significant number of records are deleted, isn't it? Yeah, that looks like quite significant number of records are deleted out of it. Why is that so? There were not much number of records. Okay, let me say less than or equals to 37 47,000, sorry, 47 years. All right, this is this is it. So I'll just go ahead with this. Okay, so this is done. Now next thing which I'm going to look into is, let me just again have a describe thing. Describe over here what we see. Now this looks pretty relevant, right? Person's age is, okay, let me come back over here and here also say less than or equals to 70 years. Okay, this 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 61 increased to 68, and then here it is coming 31,671. This is all right. Now this also looks pretty well, 31,000. Okay, now this is good. Here what it say is maximum age is 70 years, minimum age is 20 years, employment length is 38 years, which is good. Now the next thing which we are seeing is minimum is 0 years, minimum length is 0 years. Now pretty much in shape. Now let's just check about the null values. Okay, let's just have a look at null value. The dot is null dot sum. Let's just see. Okay, all right, so loan interest rate seem to have huge number of missing values, right? So that's something which we would require to do the treatment of. Okay, so now on rate of interest, let's have a look on the statistical descriptive statistics. What we see is loan interest rate. Where is loan interest rate? Over here. So it says mean is 11%, minimum 5% rate of interest, and average rate of interest is 11%. What is median? Median is 10%. What it means half of the data is having rate of interest as 10%. Okay, and see the maximum is 23% and minimum is 5%. So if you see, median and mean are very close to each other, right? So I think we can go ahead with either of these two. Either we can fill the missing values with median rate of interest or the mean average rate of interest. So I will choose to do this. I will do this one. Okay, so let's just try to fill the missing values into it. Again, I'm going to create a copy of this data. Dot copy, and I'm going to put it in credit risk data. Okay, this is what I'm going to do. Sorry, dot shape, and let's just see, this is good. Now let's just do one thing, this, and inside this I'm going to do, all right, so let's just try to fill the missing dot fill na, and inside this we want to fill column. Which column? This one. Okay, this column we want to fill the missing with, and the value which we want to fill the missing is this, and inside this one, and this, then I can say median. Oops, I just hit the tab key. Now it will take its own time to complete, to do the autocomplete. I'm so sorry for this. This is something which is a time consuming part. Now this is done. Let's just see if this gives an error or what. Okay, seems like it worked. Now let me try it again and check out the missing values is null dot sum. Okay, does this mean I need to say in place equals to true? Is it in place equals to true? Yeah, that's gone, right? The missing value is gone. Super. Now that is also done. After that, what else that we should be doing? Now let's again just see the describe of this data. Dot describe. So here I replace the missing values with median. Now if you want to replace that with mean, you can go ahead and do that, and if you want to replace that with backward or forward, that you can also do, right? I have a separate video on that, you can just check that out. Okay, now that looks pretty well. Okay, now let's just have a look at the number of values that we have. Okay, number of records that we have, so that we could determine whether the data is balanced enough or not. Okay, so how can we determine that? That's basis on the loan status. So what I'm going to say is group by loan status and dot count, and I can pick any column, let's say person age. Okay, so this still looks kind of imbalanced, right? If you will see this, then we can let's just do a quick calculation. This divided by this plus this. So approximately 21% of the records are positive, and so let's say 20% of the records are positive, rest 80% is negative. The balancing will be when you have 50-50, right? If you have 50% of the data as positive, 50% as negative, or if you have at least 60-40, then I will consider it, at least in my thought, I will consider that as balanced data. So remember, take a note, we would require to do the balancing of the data also, but not at this point of time, we will do it in some time. Okay, first let's just, now we are done with missing values treatment and some unpractical data removals, right? Next thing, let's just have a look on the categorical data. Let's have a look at categorical data. Let's just have a look on that. I'm just going to print that data again, this one, and let's just have a look at the head of it. What it shows is there are two categorical columns, this one and this one. Let's take a group by, let's just take it one by one. Cr data dot group by, and inside that let's just see how many categories are there, what all are the categories that we have. I mean, this is the way which I prefer. You can always have a different way of doing the things, that's absolutely fine. Okay, and I'm just going to take this one, and let's just see. So there are four type of loans: mortgage, no, sorry, home ownership, right? Home ownership, there are four category of home ownership. One is mortgage, other own and rent. Now let's just have try the same thing. I'm just going to do the same thing for this variable, loan in intent. For what purpose the loan, the person is taking the loan, right? Now let's just see, there are how many possibilities, I mean how many reasons for which the particular person is taking loan. That is 3 and 3 six reasons. So like you can see, this is categorical column. Now to treat this in model, to put it, we require to have it in numeric form. So how do we, okay, there is one more, this loan grade. I don't know the importance of this loan grade, but let me just see. Because let me have a look if it has the definition also. Loan grade, the definition simply says loan grade, it does not talks a lot about it. So if it has some more values, then I would just think of dropping that. loan grade. Let's just see what is the distribution. 1 2 3 4 5 5 6 7. These are just 7. I can still think of keeping them. Right, I can think of keeping them, or what we can do is we can think of grouping them. But in my thought, what's going behind in my mind is I should drop that because I don't understand the meaning of it. I don't even understand the meaning of it. So I don't see any point of keeping it. I'll drop it. Okay, I'll just drop it. So let's just say credit risk, credit data. Again, I will create a copy of it. Data copy, and over here I'm going to say this drop. Let me just see the parameters of it. Okay, I can simply write the column name. The column name is loan grade. I'm going to drop it. If you want to keep it, you are more than welcome to do that, and let me know the performance of your model. I would also learn from that. Okay, something went wrong. Levels index column. Okay, I index. Why did I write index equals to? I should say in place equals to true. But first let me say this, in place equals to true. Okay, let me remove it from here. Done. Non-type object has head, so it has removed everything, is it? Okay, let me see, where did I just I had created a copy of it, isn't it? Okay, I did something wrong. Okay, let me just see if this still has the data. Okay, this has the data. Now over here there's something wrong. What exactly? Non-type object has head. When I'm removing it, so I should say drop, and inside that I would say loan grade and axis equals to 1, and let me put it, I would say dropped. Okay, let me first create a copy of it. Oh god, I'm taking a lot of time. Copy equals to this dot drop, and inside that I would say loan grade axis equals to 1, and let's see what happens. Why is it saying loan grade not found in the axis? Loan grade, where is that grade thing? I had it here. This now I don't see that. Is that gone? It looks like that is gone. Group by. Okay, so I think that is already dropped, and that is already dropped, so we don't need to worry about it. Okay, CR data, or what we can do is CR data. Is there any CR data? Where did I make a copy of this? CR data here. Here I had made the copy of that. I'm just, now you see how important is it to have a checkpoint in your data. Now it just worked, and let me just see if what is the shape of it. Now this is done. This looks pretty much well, pretty good. Okay, so after dropping that, I've created a copy. So let's just not go by the name at this point of time, and let's just be with this naming convention. Okay, now this has only 11 records, means loan grading is gone. Okay, now the next thing which I'm going to do is I'm going to you know they do the treatment for this categorical columns. I think this video is quite long, so I'll pause this, and in the next video I'll do the treatment for the categorical columns. Thank you very much for watching this. See you in the next